Alrighty then, back into the swing of things, taking it one step further, and this is the last step, the last kind of questions you're going to have to deal with, which is ultimately doing the factoring, which I had mentioned in our previous videos, where we're just going to have one extra step next week. Well, here we are. This is it. And hopefully you recognize your factoring things that can be done with these trig stuff. Alrighty. Okay, so this one actually, I'm going to approach it through factoring, although you could add 1 and divide by 4 and then square root both sides. And don't forget the plus minus thing if you were going to take that approach. But I'm going to go ahead and take this as a difference of two perfect squares and solve this through factoring. Perfect square of 4 sine squared is 2 sine. Good FOILers are good. Anyone? Factors. All right, 2 sine times 2 sine would be that 4 sine squared. And then it's the old minus 1 plus 1 because negative 1 times 1 is negative 1. And then negative 2 sine and positive 2 sine would cancel. That's why there's no middle term. So there you go. Solving by factoring. And then this is what I said last week on Thursday. We had questions that were presented in this format, already in factored form. And then we used the zero product property to solve from here. Right, so add 1, divide by 2, subtract 1, divide by 2, and you end up with these two equations, I guess. And then you notice that this is y over r, so y is, like you were saying yesterday to get this memorized, the side opposite the reference angle. This is a 30, 60, 90 set of sides, where the x side would be root 3. So anyway, these are all 30s. And this is a 30 in quadrants 1 and 2 because that's where sine is positive. Don't forget ASTC. All students take calculus. And then these are 30s in 3 and 4 because that's where sine is negative. So to satisfy the first set of directions, we'll solve between 0 and 360. I'm not going to do it for all of these. I just wanted to make a note to self. Maybe on just number 1, I'll show how you do all solutions when you get this. But between 0 and 360, these would be the answers. 30, that's the quadrant 130. 30 short of 180, 150. 30 past 180 is 210. And then 30 short of 360 is 330. And then if you look at these answers, these two sets of answers are 180 away. These two sets are also 180 away. So when we go to, and I'm only going to do it on number 1, finding all solutions, we can write that as an expression 30, the first one, plus, since these are 180 away, we can do 180n, and that takes care of these two sets of answers that will always land on one or the other coterminal. And then 150 we'll choose, and that is 180n away, to generate all the answers that land on 150 or 330 because they are 180 degrees away from each other. All right, so hopefully that makes sense. I won't do that for 2 and 3. I'll just do between 0 and 360. I just wanted to make a note of it, so that you're ready for that. By the way, yeehaw. Okay, and now we can move on. All right, this is the kind of factoring for this is GCF factoring. And we need to look at that in those ways. This is like x squared plus root 3x equals 0, where x would be the greatest common factor. And again, getting yourself trained to think of trig like variables. All right, I try to leave that there because I think this is going to be kind of a short one. Break this down, plus not doing all answers will shorten up the space. When I take a tan out of a tan squared, it's left with a tan. When I take tan out of this, it's just a root 3 all by its lonesome. And then that's equal to 0. Now what I'm able to do is do the zero product property, setting these parts both equal to 0, because if this times this equals 0, either that or that has to be 0. Lost my minus. I think I wrote it in the old disappearing ink on this program happens all the time. And then add root 3, and then you're done with that one. All right, I think we've had this a few times with tangent. Tangent's y over x, and this 1 could actually be plus or minus 1. So just be aware of that, that this is, where this occurs is 0 for y and 1 for x, or 0 for y and negative 1 for x. These are 0 degrees and 180 degrees. And then where is tangent positive? That's quadrants. I'll use the same coordinate plane to kind of use this. This is y over x. There we go. Y and x is 1 and root 3. R has to be 2. This is a 30, 60, 90, where it's a 60 that I'm looking for a reference angle. That's 60 and that's 60. All students take calculus. Fumble. That was my pen I just dropped. All students take calculus. Take means tangents positive in quadrant 3 as well. So probably when we write these in multiple choice, we'll order them better. I'll probably write 60 degrees second, and then 180 third. But whatever. I think we are okay with writing this like this and understanding. And that would be 240. Okay. And I'm not going to write all the answers, but I could talk about them. It would be 60 plus 180n because those are 180 away. And it'd be just 180n for these because I plug in 0, I get 0. I plug in 1, I get 180. Plug in 2, I get 360, which is back to 0, so on and so on and so forth. So I could verbalize those answers. Oh no, what do we have here? Panic in the streets. I threw this in here on purpose because I wanted to at least talk about a little bit of chapter 5 and what, this is a little bit more involved, meaning I can't factor these. These don't, if I subtracted the sine square, but then also subtract the 1, you don't have a difference of 2 squares. That wouldn't work. And we got a problem. And the problem could be very simply taken care of from chapter 5. Just remembering, and don't panic, but we should remember some things, This one was used quite a bit in our last chapter, the Pythagorean identity. Sine squared plus cosine squared equals 1. And if I went ahead and subtracted cosine from both sides, then sine squared is equal to 1 minus cosine squared. You're going to want to do this on this one because now at least you have the same variable you're dealing with. Cosine squared now. So you got it in similar terms is the best way to say that. So substitution. That's what sine squared is equal to, and now I can work with this one. What's interesting is I'm going to go ahead and add cosine squared to both sides. But then what I'm going to do is I'm going to leave 1 plus 1 equals 2 over here and just divide by 2. Both sides. 2 divided by 2 is 1. Then you square roots, and don't forget, when you square root both sides, it's plus or minus 1 over 1. Okay? That just happens when you square root both sides to solve. All right? We got to remember that. That's something that's been brought up all year long. It's one of the original burn questions. People can't keep making the same mistakes over and over and over again. Remember the rule. All right, so we're going to get an x of both positive 1 and negative 1, and then an r of 1, of course. Well, I think we already had that one, and that happens here and here. Y would have to be 0 through the Pythagorean theorem. So it's 0 and 180 degrees for this one. All right, halfway there. Okay, switching it up to radians, and I'll probably just do the first one where I do both this and then all, just to remind yourself of that one. All right, so hopefully we see right away that this is a difference of wrong, wrong, wrong. This is a greatest common factor scenario. I pull out a cosine of x, and then I'm left with 2 cosine x. Cosine squared becomes cosine, because if I throw it back in, then it's cosine squared again. Good distributors are good factors. Minus, you pull out that cosine, it's just a root 3 all by its lonesome. Zero product property. Cosine of x equals 0. And then add root 3, divide by 2. Cosine of x equals root 3 over 2. All right, 0 over 1, x is 0. r is 1. Um, so there's two spots where x could be 0, so that's where we have to kind of understand that. You could be 0 for x, and then 1 for y, and then be up here, but also 0 for x and -1 for y. It could be one or the other when you set up the Pythagorean theorem and solve for this one. So you have two answers for that one. That is going to be pi over 2 and 3 pi over 2. Here, this is x over r. That means y has to equal 1. Again, remember, opposite side of the y is the reference angle. So this is a 30. And where is cosine positive? 1 and 4. So I have a 30 in 1 and I have a 30 in 4. ASTC. Um, all students take calculus. Just reiterating these things over and over again so you understand. All right, so writing my answers. What are the 30s? They are the over 6's. So the 30 in quadrant 1 is pi over 6. I'll go ahead and write these in order. I'll write that pi over 2 second represents the 90 degrees. Then the 3 pi over 2, that's the 270 degree angle from cosine of x equals 0. And then the last one, the 30 in quadrant 4. 12 pi over 6 is 2 pi, so you jump back 1. 11 pi over 6. All right, those are the answers. Now I did say I was going to show all answers on this, just this one. For all, these two are special. They are 180 away, or in this case, pi away from each other. So I get to pick one, pi over 2, and just add pi into this because they are pi away from each other. And that takes care of this and all angles that land in those spots. Whereas these two, these are not the same distance away from one to the other. So what's nice about that is you just get to say pi over 6 plus 2 pi n. That generates all answers that will land on that spot. And then 11 pi over 6. This is the kind of question where you can just go ahead and tack the 2 pi n's on. We had some special ones in the first case when we had degrees where they were actually both sets of answers were 180 away, so I can do that. These I cannot. So, all right. All right, our first time where we get a little bit of a MA factoring. And if you've noticed, we've always wanted 0 on this side in this solving by factoring so that we can do the 0 product property if we're able to factor. All right, subtract 1. Now, I'm not doing any fancy MA, situation where you take 2 and multiply by -1. I have tried to train my students to be good foilers, gosh forbid that four-letter F word, all right, and understand that 2 cosine times 1 cosine is 2 cosine squared. So we're going to have two sets of binomials when we factor this out. And then the only thing that could equal -1 is 1 times -1, the last of FOIL. That's what we're doing when we're factoring. We're unmultiplying it, and in this case, two binomials. So where does the 1 go? Well, if I think of outer, I have a -1 cosine as a middle term. So I want that -1 here and a +1 here, because then -2 cosine plus 1 cosine is -1 cosine. And then, of course, 2 cosine times cosine is 2 cosine squared. 1 times -1 is -1. If you don't understand that, you're not really understanding what the point of factoring is and the whole idea of it. You should always know what it is the reverse of. Tried to hammer that down all year long in my classes. Good foilers, anyone? Good factors. There's my dog barking. Cosine, Scruffy. I'm in the middle of something. All right. Where's x1 and r2? Not where, what? That means y is root 3. This is a 30, 60, 90. Okay, now I can ask where's cosine negative, and it's 2 and 3, because cosine's positive here and here. That's not what I have. I have negatives. So you have a 60 in quadrant 2 and a 60 in quadrant 3, because root 3 is the opposite side. Then just real quick, 1 over 1, x is 1, r is 1. this is only going to be one answer because there is no positive or negative possibilities when you have 0 as your ratio. So there's only one spot where x is 1, and it's here. Y would have to be 0 through the Pythagorean theorem. All right, so that's 0 radians. All right, so I have 0 radians is one of my answers. What's the 60s? They're over what's? We don't know that at this point. We're severely, anyone? Behind. This is 3 pi over 3. So jump backwards, 1, that's 2 pi over 3. And then to go into quadrant 3, you jump forwards a pi over 3. And that's 4 pi over 3. All right? And I'm not going to do all answers. I'm just going to do between 0 and 2 pi. There you go. All right, moving on to the last one. Hey, what is this? Okay, and I threw in these weird ones that were in our old notes from last year that you don't know about. And I thought, you know what? It's not going to be harmful to do this one, just like it's not going to be harmful to do this one where you didn't have the same trig, which seems to be the case again. The escape on this one was, a Pythagorean identity switch, I guess, or exchange or substitution, better math word. And then you have the same variable. I use that in quotes, saying cosine squared is variable. So the problem with this one is I don't have a Pythagorean identity, but we should know immediately that cosecant is 1 over sine. And that's what we're going to do. And then I know I like fractions, but if I can avoid them, I will. I'm going to use a nifty little idea of whatever I do to one side, say it, you do to the other. And this is what you would do when you have fractional equations or fractions in equations. You multiply both sides by whatever the common denominator is to get rid of those fractions. But you got to do it to both sides. All right, so on this side, we get 2 sine squared of x minus sine of x. And then on this side, it just equals 1. And then I'm going to go ahead and subtract that 1 just for purposes. You should know sine times 1 over sine is 1. And then I have to subtract that 1. So this, it's not this one is minus sine x when you multiply by that. So anyway, you know this equals 1, and then I went ahead and subtract it. And then look, it's the same exact polynomial, except it has sines instead of cosines. So it's going to be the same exact factoring on this one. 2 sine of x times sine of x is 2 sine squared. And then we want the minus 1 here again because minus 2 sine x and plus sine x gives me a negative sine x middle term. Okay? But now we're going to get different answers here because we have a different trig. This time sine of x equals negative a half. And then sine of x equals 1. All right. So we have our y is negative 1, so that means the reference angle, because it is a 1 root 3, 2 situation, a 30, 60, 90, where it's a 30. And where is sine negative? Well, not in 1, not in 2, 3 and 4. So I want a 30 in 3 and a 30 in 4. And then where is sine equal to 1? Y over r. Another case where this is just going to be one answer, and it's got to be up here. That's where you get a y of 1 and an x of 0. Putting that as a coordinate. Over here, the coordinate was 1, 0 for 0 radians. Remember, this is coordinate trig. What does the terminal side pass through? Anyway, what are the 30s? They're over what's? 6's. Remember, this is 6 pi over 6. Jump forward, and that's 7 pi over 6. I already wrote this before. This is 12 pi over 6. Jump back, and it's 11 pi over 6. Oh, and I should have put this first if I were going to keep these in order. This is pi over 2 for the second part, sine of x equals 1. All right, done deal.